Okay, let's be honest. Most of us, and I mean almost everyone, use the words speed and velocity like they're the exact same thing. But in the world of physics, oh, they are worlds apart. And today, we're going to clear up all that confusion for good. So let me ask you this right off the bat. You're in your car, you glance down at the speedometer, and it says you're going 60 miles per hour. Is that your speed or is that your velocity? Go on, take a guess. By the time we're done here, you are going to know the answer to this, no problem. It seems simple, but it gets to the heart of what we're talking about.
All right, before we can even begin to talk about how fast something is moving, we have to agree on something way more fundamental. Where is it in the first place? And that brings us to our starting block, the idea of position.
Now you might think position is easy, it's just your location. But if I say a car is 10 meters away, well, that's not very helpful, is it? 10 meters away from what? A tree? A stop sign? My house? For position to mean anything useful, we absolutely need a fixed reference point. Physicists have a simple name for this, they just call it an origin. So here's the big takeaway. Position isn't just a number, it's a number and a direction. First, we set up our starting line, our origin point, our zero. Then, we decide which way is positive, let's say that's to the right, and which way is negative, to the left. So now, if I say a car is at plus 10 meters, you know exactly where it is. It's 10 meters to the right of our starting point. And this brings us to our first key bit of vocab. Anything in physics that has both a size, or a magnitude, the how much part, like 10 meters, and also a direction, like positive or negative, has a special name. It's called a vector quantity. And you guessed it, position is a perfect example of a vector. Burn that word into your brain, because it's going to come up again. Okay, enough with things just sitting still. Let's get moving. And when we start to describe how quickly an object's position is changing, well, that's when we're talking about velocity. So what is velocity really? It's just a measure of how fast an object's position is changing over a certain amount of time. And the formula for it? It's beautifully simple. You just take the change in position and you divide it by how long it took for that change to happen. That's it. Let's see this thing in action. It makes way more sense with an example. So, picture a number line laid out on a road. We've got a car that starts at the plus 10 meter mark and it drives over to the plus 25 meter mark. And this little trip takes exactly 3 seconds. Okay, first things first, let's figure out the change in position. We just take where it ended up, plus 25 meters, and subtract where it started, plus 10 meters. That gives us a change of plus 15 meters. And pay attention to that plus sign. It's telling us the direction of the movement was to the right, in the positive direction.
And how long did this all take? Well, the problem tells us it took 3 seconds. So now we've got both pieces of our puzzle.
Now we just plug them in, we take our plus 15 meters and divide it by 3 seconds, and we get a velocity of plus 5 meters per second. So what does that mean? Well, the plus sign tells us which way it was going, to the right, and the 5 tells us how much its position was changing by 5 meters every single second. See? It's a vector. It's got magnitude and direction. Okay, so that's velocity. But, what if we just don't care about the direction? What if all we want to know is how fast was it going? Period. We don't care if it was going left or right. Well, my friends, that's where speed comes into the picture. So let's flip the script. Let's run a new scenario. This time, our car starts at the plus 25 meter mark and it moves backwards to the left, ending up at the plus 5 meter mark. And for this trip, it takes 5 seconds. Let's do the velocity calculation again. The final position is 5 meters. The initial position was 25. So 5 minus 25 gives us negative 20 meters. We divide that by the 5 seconds it took, and bam, we get a velocity of negative 4 meters per second. That minus sign is everything. It's telling us the car was moving to the left, in the negative direction. So its velocity was negative 4. But think about it. Would you ever tell your friend you were driving negative 4 miles per hour? Of course not. That sounds crazy. And this right here, this is the exact point where speed and velocity go their separate ways. When we calculate speed, we throw direction out the window. We don't care about positive or negative signs. All we care about is the total distance the car covered. In our case, going from 25 to 5, it traveled 20 meters. So we take that total distance, 20 meters, divided by the time, 5 seconds, and we get a speed of 4 meters per second. Simple as that. Notice, speed is always a positive number. And that brings us to our other key term,
A quantity, like speed, which only has a magnitude, the how much part, but has no direction associated with it, is called a scalar quantity. So let's get this straight. Velocity is a vector, speed is a scalar.
All right, let's really lock this concept in. I've got one final killer example that's going to make the difference between speed and velocity absolutely crystal clear. This is probably the best way to think about it. Imagine this. You leave your house, you drive to the grocery store, you pick up some milk, and then you drive right back home, parking in the exact same spot you started from. A complete round trip. So, let's think about your velocity for that whole trip. Remember, velocity only cares about your change in position from start to finish. Well, where did you start? Your driveway. Where did you end? Your driveway. Your overall change in position is 0, nothing. And 0 divided by any amount of time is still just 0. So your average velocity for the whole trip was 0.
But wait a minute. Did you actually go nowhere? Of course not. Tell that to your gas tank, or look at your car's odometer. It tracked every single mile you drove to the store and back. That's the distance you traveled. And since you traveled a real positive distance, your average speed, which is that total distance divided by the time, is definitely not 0.
So let's just boil it all down right here. Velocity measures the change in position, it has a direction, that plus or minus sign, and it's a vector. Speed, on the other hand, measures the total distance you traveled, it has no direction, and it's a scalar. This little table is pretty much the whole shebang right there. And that brings us all the way back to the start, but with a new little brain teaser. Next time your GPS says, in 200 feet turn right, ask yourself, is that a speed or is it a velocity? Because it's not just telling you how far to go, it's also telling you which way to go. Something to chew on. Thanks for watching.